Alright guys, so in this video we're going to go over 3 problems real quick. When we're doing fifth roots, or any number you see next to the root, is basically the number of pairs you have to find. In this case, we have to break down this 32 and find 5 prime numbers that are the same so we can take them out. Let me show you an example. So let's break down the 32, guys. 32 gives us, isn't it 8 times 4? It could also be 16 times 2, etc. But it's the same thing you're going to see right now. Notice how the 8 and the 4 are not prime numbers because you can still break them down. Let's break down the 4. That's 2 times 2. And the 2's can no longer be broken down, so I'm going to circle them just so I can remind myself it's a prime number. Let's break down the 8. The 8, isn't it 4 times 2? And I know the 2 is a prime. We're going to circle it. And finally, the 4. That's 2 times 2. And those are prime numbers as well. So we're going to circle them as well. Now, what did I say? We're trying to find the same prime number that appears 5 times so I can take it out. So if you notice, the 2 shows up 1, 2, 3, 4, 5. So I can actually take all of them out and just put a 2 outside of the square root. Now, what are we left in the inside? Remember, the 32 is always, any number is always being multiplied by a 1. So what's the square root of 1? Simple, it's just a 1. So what's 2 times 1? It's basically just 2. So you just found the answer to the fifth root of 32. Another way you could have written this, guys, you might see this on the homework. You can see it that way, or you can see it 32 to the power of 1/5. Just remember, this is the same. It's just another way of writing the fifth root of 32. All right? And that's basically it. My answer would be just 2. Now, going to another example. The fifth root of 243. Again, another way of writing this is 243 to the power of 1/5. It's the same thing as saying the fifth root, okay? So whenever you see either one, basically you're finding the fifth root. Let's break this one down, guys. Now, 243 is kind of crazy. I don't know. I recommend you use a calculator and just play with it. Make sure you find a good number you can reduce it by. So let's just play it safe. 243. Let's first try to divide by 2. And I get a decimal, 121.5. So you know what? Let's try again. 243, and let's keep going up the numbers. Divide by 3. Look at that. I got a 81. So we found one. So we have 81 times 3 gives me 243. You can check yourself in the calculator. Now we know 3 is a prime number. Let's circle that bad boy. 81, let's break it down. That's 9 times 9. And those are not prime numbers because we can keep breaking them down. That's a 3 times 3. And that's a 3 times 3. And we found ourselves all the prime numbers. Now what do we say? We're trying to find 5 prime numbers that are the same. And look at this. We have 1, 2, 3, 4, 5. So we get all those 3's. We take them out of the square root, or fifth root in this case. So that's going to be a 3, the fifth root of 1. And the fifth root of 1, you can always check, is always a 1. Anything 1 is 1. So 3 times 1 is just 3. I just do that just to make you see that the fifth root doesn't just disappear. And that's your answer. And same thing for this one, guys. Again, that's the fourth root of 625. Another way you can see this in the homework would be 625 to the power of 1/4. Let's break it down, guys. Let's try it again. Use a calculator just to see which numbers you can divide it by. If we divide by 2, we get a decimal. If we divide by 3, we get a decimal. If we divide by 4, we get a decimal. If we divide it by a 5, oh, look at that. 125 times 5. That's 625. We know 5 is prime. Let's do the same thing with 125. 125 divided by 2 is a decimal. Divided by 3 is a decimal. By 4 is a decimal. Look at that. By 5. 25 times 5 is 625. And we already know 25 is 5 times 5. And look at this. You'll basically get four prime numbers that are the same, which is exactly what we're looking for. Take it out. So it's a 5, fourth root of 1, but the root of 1 is always 1, so it's 5 times 1 is just 5. Now, these are examples are perfect roots. What I say that is that there's always going to be something. There's never going to be something left inside the root. Sometimes there will. And that's something for another lesson.